Welcome to the last part of the energy tokenization section. In the first few modules, we discussed the token and digital tokenization and its application in the energy sector respectively. Lastly, we will discuss use cases like fractional ownership and the different aspects involved with it. One of the aspects in renewable energy investments is the lack of financial instruments to accelerate the energy transition. With the initiative that I'm about to discuss, we hope to have a positive impact on the acceleration of those investments. For energy tokenization, the aim is to create a sound-based model by linking multiple value streams associated with renewable energy. We start with the shared ownership. For instance, let's say we want to sell the ownership of one solar panel of a solar farm. For this, we create a token for each single panel. This token not only represents the intrinsic value of the panel, but also covers other value streams associated with it. Such stream is the power offtake, which is the ability to trade the energy generated by the panel. This can be done over the counter with power purchase agreements or through the energy market. Another offtake is the actual energy being generated and delivered to a consumer, for which in the end is being allocated and then cleared and settled. Another aspect is the certification offtake, which is then with the energy that's being generated is most likely be eligible for certificates of origin, and the income through this can be associated to the panel. Energy tag offtake is another aspect which started in the UK for real-time energy tagging. And last but not least, we have data offtake, for instance hyperlocal green signals, or data associated with asset aging compared to cleaning cycles. With all these data stacked together, then the ownership of a single panel will generate income for the years to come. This way of tokenizing energy is classified as fintech, and one of the interesting aspects like to learn and to understand the market relevance that we want to evaluate when we launch this concept in the market. Using the notations in the second module to depict the different tokens, we get a picture like this. On the blue part on the top, there is asset ownership, representing, for instance, one solar panel. This works as an anchor token to all the other tokens representing the power for trading, the energy for the energy trades, the guarantees of origin or renewable energy certificates, real-time energy tag, and the different types of data like green signals, time of use, a trigger for temperatures. Certification and real-time energy tagging is another emerging and intriguing aspect of this setup. One of the ways is starting with the energy tag. You generate an energy tag for each program time unit for the unit of kilowatt hours generated, and the non-used energy tags can then be offered to an exchange that accepts this energy tag certificates and converts them into a coin representing a traditional certificate of origin with a 1-year lifetime. This is a proposal under discussion with energy tag. Among identified platform participants, corporate investors are the initial investors for the assets which they can sell off to the interested parties along with the data associated with it. This moves the asset from the balance sheet of the investor to the new owner. The power trader is associated with the setup of the power in the power purchase agreements and can trade on the balancing market. There is also constructs agreements with Renewable 100 companies for commercial and industrial use. The generator's interest lies in the energy delivery for the real-time energy tag specification, specifically targeted for Renewable 100 companies, as these companies are expected to be the first issuers and buyers of real-time energy certificates. The certificate issuing body and certificate traders owning those certificates can sell them to energy suppliers in order for them to write it off to be compliant with regulatory frameworks. A stack-layered approach is needed to build this whole solution, and for this I created this layered stack inspired by Hyperledger Aries project. It starts at a layer 0 with crypto anchors, which are the trusted links to the physical world. So crypto anchors are the equipment in the IoT layer and the first digitization to ensure data reliability. The second one is the token layer, which codifies the representation of values being collected by the crypto anchors. The The red box describes the scope in the 2021 project of the 2 tokens energy project. If we have the tokens, then the layer 2, a protocol for peer-to-peer transaction between actors is required. And based on that two-party protocol, we can extend it to build exchanges leading into markets and add discovery mechanisms of actors and can facilitate transactions. In layer 4, we support ecosystems by constructing value-add networks by combining energy networks with emissions, electrical vehicle networks, finance, etc. In the verticals, you see the different aspects that are needed to address the use cases shown. So the token taxonomy, legal aspect, finance, taxation, commercials for business, and advocacy to ensure that your token and system is known to the world. So now let's see how the ecosystem can look like when these tokens are used. In this ecosystem, we have 6 elements. So trust in the information without which the whole project will fail. And the second aspect is the blockchain or distributed ledger technology to deliver the single version of the truth to all parties involved. The third element is a permission blockchain to ensure all parties are known to the system and we can be compliant with the regulatory framework. The fourth element is the crypto anchors to ensure data reliability. The fifth aspect is the AI and machine learning to detect fraud and optimize trading. And lastly, the blockchain mesh allows multiple business networks, each with their own technology stack, to use the same concepts and are also able to exchange the tokens between the networks. Now let's look at a challenge. If we create these token-based exchanges, the value that there are then in the different value streams, which can be stacked and discussed, and some of them are traded on forward and futures market, trading on spot market and intraday market, trading for balancing, and finally there will be congestion markets to find anticipated congestion introduced as the new loads are coming to the grid. Hence there is an opportunity, as shown by the red box here, to create a market of markets that should safeguard the much needed emergent effect as discussed in Module 2. However, this is outside the scope of the project and hopefully it will be picked up later. So the current project is active, but we still need contributors. So if you want to contribute to this exciting project, please reach out to me or look the project up at the 2tokens.org website. In this module, you've learned a fintech application of digital tokens in the energy sector and the existing challenges to extend this into a market of markets application. This concludes the module on energy tokenization. I thank you for your attention and I hope to see you soon.